Hello, this is Mr. Painter with another fabulous IXL. We're working on O12 today, exterior angle theorem. Before we get started, let's take a look at our notes and see exactly what are we doing today. So to the right side, if you take a look at our notes, the key idea is here, the measure of the exterior angle of a triangle equals the sum of the two remote interior angle measures. So for an example, if we're looking for angle 2, we're going to add up angle 3 and angle 4. Now, you're probably wondering, well, why do they have the M in there? What does M stand for? What does it mean? Because I don't see an M inside the triangle. Well, the M means the measure of angle 2 equals the measure of angle 3 added to the measure of angle 4. So again, M represents the word measure. So what we're doing is we're adding opposite angles across from the exterior angle to get the missing measure of angle 2. Now, we're also going to use all angles inside of a triangle must add up to 180 degrees. That's going to become useful as our SMART score goes up. Between those two things, that's all we're going to need for today. All right, let's go ahead and get started. So first question we're looking for is, what is the measure of angle 1? So notice that to find the measure of angle 1, according to our notes, we're going to add the measure of 51 degrees plus the measure of 95 degrees. So here's what that looks like. Measure of angle 1 equals 51 degrees plus 95 degrees. And notice I have a calculator open, so don't make things more difficult than they have to be. So if you have a little handheld calculator, that works too. So we're just going to use our online Google calculator, because if you're on the computer doing your IXLs, well, chances are you have another tab open that could be using a calculator as well. So 51 plus 95 is going to take us to measure 1 being equal to 146 degrees. Okay, and notice that measure 1 right here, because it's obtuse and it's a pretty large angle, kind of makes sense that it should be 146. So just kind of check it real quick. Does it make sense? In this case, yes. So measure 1, 146. And give you a little minute to look at it. It's our first question, because that just gave us a score of 10 points. All right. Okay, we got another question. We got the measure of angle 1 equals two angles across. So we're going to add 44 degrees plus 32 degrees. And handy dandy calculator is going to get us 44 plus 32 degrees is going to take us to 76 degrees. So the measure of angle 1, because it's just added up to 44 and 32, is we're going to go ahead and type in 70 degrees. Now, notice the degree sign's already next to the box, so all you got to do is type the actual number, and the degree sign's automatic. So I'm typing literally 76. Don't type the degrees because it's already there, and that's how you get it. All right, so it continues. Very similar problem so far. So again, measure 1. So we got measure of angle 1 equals 34 degrees plus 63 degrees. So handy dandy calculator is going to go ahead and add them up. So we got 34 plus 63. It's going to take us to 97 degrees. So 97. Again, check it. Now, if you notice measure of angle 1, it's a little bit bigger than 90 degrees, so it makes sense. It should be 97. All right, and let's go ahead and submit that. Perfect. All right, so far so good. We're at a SMART score of 28. We got the measure of angle 1 equals 65 degrees plus 52 degrees. And measure of angle 1 is going to be equal to just simply adding them up. So here we go. We got 65 plus 52 equals 117 degrees. So 117 degrees. So we're going to go ahead and put 117 degrees, 117. And here we go. All right, looking for the measure of angle 1. Now notice the measure of angle 1 is no longer on the exterior angle. So we got to be a little bit different in how we solve this. So I think the first thing is we want to use is something called supplementary angles. by using supplementary angles here, we're going to find the missing angle here of x. Then take 180 and subtract 53, subtract the x, and that's going to give you the 1. So that's what we're going to go for. All right, so first step, using supplementary angle theorem, we got 180, subtract 149 equals x. And go and solve. We got 180 minus 149. It's going to take us to 31 degrees. So we got 31 degrees here. And 31 degrees equals x. Now, because that was a supplementary angle theorem, and I'm noticing right here, all angles that have a triangle must add up to 180 degrees, we can take 180 degrees and subtract out your 53 and your 31. So 180 minus 53 minus 31 degrees, these are all in degrees, equals your measure of angle 1. Let's give that a try and see how it works out. So we got 180 minus 53 minus 31 equals 96 degrees. And take a look at angle 1. Notice it's just a little bit bigger than 90 degrees. So 96 degrees should make sense. So we're going to go ahead and put 96 degrees. And just to finish the written explanation, 180 minus 53 minus 31 is 96 degrees equals, again, measure of angle 1. Okay, we're at 43. So back to a normal problem. We got the measure of angle 1, which is on the exterior angle of the triangle. And we got 33 and 39. So in this one here, we can take the measure of angle 1 equals 33 degrees plus 39 degrees. All right, calculator. We got 33 plus 39. It's going to take us to 72 degrees. So measure of angle 1 is equal to 72 degrees. And double check it. It's a little bit less than 90 because it's kind of more, it's not really a right angle, but it's kind of close. So a little less than 90 being at 72 seems reasonable. So here we go, 72 degrees. All right, next one. We got measure of angle 1. Notice that angle 1 is not on the exterior. It's within the interior of the triangle. So my first step is I want to use the supplementary angle theorem and figure out what is the missing angle by using 180 degrees. So 180 degrees minus 149 degrees will give us the measure of angle x. And here we go. We got 180 minus 149 equals 31 degrees. So we got 31 degrees. Now, if I remember, 31 plus 60 plus measure of angle 1 will equal to 180. So we can do that. 180 degrees altogether in triangle equals 31 degrees plus 60 degrees plus measure of angle 1. Start subtracting them out. We got subtract 31 degrees from both sides. So minus 31, minus 31. So we got 180 minus 31 gives us 149. So we got 149 degrees equals 31s are out. 60 degrees comes down plus measure of angle 1 comes down. All right, we got our next step. So we got 60 degrees plus measure of angle 1. So I want to get measure of angle 1 by itself. So subtract 60 degrees from both sides, minus 60 degrees. So 149 minus 60, ooh, that's a good one. 149 minus 60, calculator is 89 degrees. So we got 89 degrees equals 60s are out, measure of angle 1. So measure of angle 1 is almost a 90 degrees, so 89 degrees. And notice here, it is almost a right angle. Almost a right angle. What I'm going to do is I'm going to turn that box into a curve because that box means exactly a right angle. But because it's so close to a right angle and I can see it and it's 89 degrees, I can almost be confident I got this one right. So measure of angle 1 is 89 degrees. So let's go ahead and dial in 89. One more quick check of the notes if you need it. Pause the video if you need a little bit more time on this one. Not hard, just 2 steps. Supplementary angle, theorem, use 180. And everything inside the triangle also adds to 180, so just find what's left to add it to 180. If you want to check it, 31 plus 89 plus 60 should add up to 180. So that's a good way to check it if you're like kind of scared about losing points. I feel confident, so I'm going to move forward. I definitely got it right. All right, clear the board. All right, we're back to exterior angle theorem on this one. So we got measure of angle 1 equals directly across, so this one works out nice, 44 degrees plus 97 degrees. And just simply use the calculator. 44 plus 97 equals 141. So measure of angle 1 equals 141. Makes sense. That's a really big, large angle, obtuse. And just to perfect this problem, that is in degrees. So measure of angle 1 is 141. So we're going to do 141. All right, another straightforward problem. We're looking for the exterior angle here, and we have our 2 angles directly across. So we can just simply find measure of angle 1 is equal to 50 degrees plus 80 degrees. And because they're in 10 base, that makes it easy. So 5 plus 8 takes us to 13. Add the 0, 130 degrees. Yeah, you like that trick, huh? All right, so measure of angle 1 is 130 degrees. So 130. All right, next one. Be careful on this one. Notice that angle 1 is on the inside of the triangle, not on the outside. So what we're going to use is the supplementary angle theorem first. Okay. Now another way too is if 142 is equal to 57 plus the measure of angle 1, we should be able to actually subtract the 57 degrees from the 142. So yet another way to do it that I showed you earlier. So actually I'm going to show you that way and see if it works. All right. So according to the directions, the exterior angle of 142 degrees is equal to 57 degrees plus the measure of angle 1. Measure of angle 1. I think this way might save us quite a bit of time. But again, there's so many ways to do this using a supplementary angle theorem, as well as just knowing that it's 180 degrees in a triangle. But let's try it. So to get measure of angle 1 by itself, the opposite of add is subtract. So minus 57 degrees minus 57 degrees, which is going to take us under or very close to 90 degrees. Let's see what happens. So 142 minus 57 equals 85 degrees. So 142 minus 57 is 85 degrees equals 57s are out. Measure of angle 1. Yeah, that seems quite a bit shorter. I could work with that. But again, I just want to show you different ways. You pick the way that works for you. But when you truly understand why these things work, you're like, oh, I get how we can do it. So it's always good to understand more than one way. And take a look, double check it. Notice that angle 1 is a little bit under 90 degrees because it's not quite a right angle. And 85 is just under that right angle mark. So it seems reasonable that this method should work. So 85 degrees based upon 142 subtracting 57. And it worked beautifully. And I think I'm going to continue that method because it was so far the shortest method. All right, next up. We got a straightforward problem. Measure of angle 1 equals 38 degrees plus 107 degrees. And add them up. 38 plus 107 equals 145. So we got measure of angle 1 equals 145 degrees. Take a look at measure of angle 1. It is obtuse. It's a very large angle, so it makes sense that it'd be a rather high number. So 145 seems like a good response for this one. All right, smart score is 72, still rolling. What we're going to use is subtraction on this one because measure of angle 1 is on the interior of the angle. So what this means is we got 128, which is the exterior angle, is equal to 91 plus measure of angle 1. I don't know what the measure of angle 1 is, but that's what we're here to solve. But if we subtract out 91 from both sides, so minus 91, that's a 91. Minus 91 degrees, that'll give us measure of angle 1. So here we go. We got 128 minus a 91 equals 37 degrees. So we got 37 degrees equals 91. They're out. Measure of angle 1. We are done right there. So we're going to go ahead and dial in 37 degrees. Real nice. Okay, now you're going to notice when you get into the mid 70s that they want to throw in the snakes, or the variable s is what I'm going to call it. But we're going to keep up with the same concept and see if we can figure out what is the value of s based upon here. Okay, notice that the measure of angle s is on the interior. So the exterior angle is s plus 33 degrees. So I'm going to keep up with that. So I'm going to call it $sign. Why? Because s looks like a 5. So I don't want to confuse my 5s with the s's. And if you watch my previous videos, I explain more about that. So s and 32. Okay, so s is our $signs. I'm going to clear the selection because I'm covering up the plus. So here we go. We got $sign plus 33 degrees on the outside, right? Equals s on the inside, $sign, plus added to $sign minus 32 degrees. You're like, oh my God, that's so confusing. Not really. What we're going to do is we're going to put s on one side and put s on the other side, or put our constants on the other side. So first step is s plus s. Well, let's call that 2s. So that knocks out a little bit there, minus 32 degrees. And the left side, we did not do anything with, so s plus 33 degrees. Now this turns into a very fantastic multi-step equation. And putting the numbers on one side, I like to add instead of subtract because that keeps my numbers positive. So what if I add 32 to both sides to eliminate our constants on the right side? So add 32 degrees, and these are all in degrees. 33 plus 32, I believe, is 65. If you're paranoid, you could check. So 33 plus 32, and there you go, paranoid, confirm, is 65 degrees. S, we haven't done anything with yet. So remember, it's $sign because I don't confuse it with a 5. Equals $sign because the 32s are opposite. Okay, we're almost done. What I'd like to do is get rid of this last $sign. So what about subtracting $1 from both sides? Minus $1. And what we got here is 65 degrees equals 2s minus, well, Mr. Painter, you didn't put a number here. How many s's? 1s. If there's an s or a $sign by itself, it's automatically 1. Makes sense? If I have a apple, well, I have an apple. 1 apple, right? So 2s minus 1s is s, and therefore your missing s is 65 degrees. Now, not really terribly difficult. Same steps. I plugged in the exact same way as I did before, so you should get used to plugging these in. And except you're just solving for S. Now, does it make sense that S right here, does it look like 65 degrees? And to me, kind of looks like it does. Well, it's not greater than 90, so it's under 90, so that makes sense that it probably should be 65 degrees. So I'm going to go ahead and try 65 degrees. And pause the video if you want to review this, or feel free to rewind it, take a look at it again. But you know I got it right. Okay, one more problem of these, and this takes us to officially 80 degrees. All right, notice that we're trying to find the value of Z. What's actually really nice here is they gave us all three angles. So we know the exterior angle, Z, I'm going to put a little bar through it to represent the actual letter of Z, plus 6 is on the one side of the equation, equals Z minus 42 degrees, which is this one here, added to, let's go ahead and clear up that 2 a little bit, there we go. Put the degrees there, plus, remember that adds up to Z minus 46. So Z minus 46 degrees. I'm putting 65, I don't know. So I'm going to try this one more time, give myself a little bit more room. So we got Z plus 6 degrees equals Z minus 42 degrees plus Z minus 46 degrees. I'd rather take my time and do it correctly than get this last problem wrong and do 5 additional problems. So it's important to take your time. I was fine with redoing this little part. Okay, we're finding the value of Z. So we're just going to solve for Z. So constants on one side, Z's on the other side. So I think what I want to do is I want to start with my 2 Z's like I did with my dollar signs in my S's last problem. So 2 Z's put together is 2Z. And what I could do is I could just do the constants as well. Well, what is negative 42 plus negative 46? Let's do that. Negative 42 plus negative 46. So negative 46. And that runs us to negative 88. So we got 2Z minus 88 degrees. So again, constants together, zebras together. The left side, leave it alone. I haven't done anything with it yet. So Z plus 6 degrees. All right, so we could either do the constants next or the variable next. I like to usually do the variable next. Then the constants are kind of cool because it gives me the final answer. So if I got a Z here and I want the constants on the, I don't know, you can put the constants on the left or the right, doesn't matter. But if I subtract a Z here because it's smaller there and subtract a Z here, what's going to happen is Z's eliminate. I got 6 degrees equals 2Z minus Z is 1Z by itself minus 88 degrees. So again, Z by itself represents 1Z. If it still bothers you, you can put a 1Z there. So that's just 1Z. Or Z by itself. Last step, we want trying to get Z by itself. Opposite of negative 88 is plus 88 degrees. But if I add 88 degrees to one side, well, I'm sure better add 88 degrees to the other side. So 6 plus 88, ooh, that's a good one. Should be 94, but, you know, let's double check. So 88 plus 6 takes me to 94 degrees. Because, again, I'm not wanting to get this one wrong. So 94 degrees equals 88s are out. 1Z is by itself. So 94 degrees is Z. Nice. So here we go. Z equals 94. All right, that takes me to a smart score of 81. If you're confused on those last two problems, notice here at the bottom, there is a help button that says solve equations involving like terms. So again, if you had a hard time understanding what I did with those last two problems with the variables, please clarify and go back to solve equations involving like terms. This will help you step by step on how to solve those. All right. Besides that, have a great day. This concludes your tutorial for IXL 012 exterior angle theorem.